Good afternoon, students. So today we are going to study on our subject engineering mechanics. We will study the unit 3. So there are various topics in the unit 3. So first topic which we will take is the projectile motion. So now you might be wondering that what is this person and what is he doing and how it is connected to the projectile motion. So basically all the like you might have seen, many of you might have seen Mahabharata, how they used to like Arjun or Karna, how they used to shoot the arrows. They were not shooting the arrows directly horizontally. What they were doing, they were putting it at an angle and then it was going. So why they were putting it at an angle? So that is what we are going to study here. So this is why, because they were making it a projectile. If they would have shot it horizontally, it would not have reached the target and it would have fallen before. Or like many of you might be playing cricket. So so in cricket, if a fielder, if he has to throw the ball back to the someone who is a bowler, so what does he do? He does not throw it horizontally, but he throws it at an angle. So what he is doing, he throws it in a way that it reaches. So if you might have also played the cricket, you also know that if you have to throw a ball, if it has to go long, you have to throw it high in the air and at a higher angle, then only it reaches. But there also there is a limit of an angle. If you throw it a big vertical angle, it may not reach very far. So there has to be an optimum angle for it to reach at a greater distance. So this is what all about projectile motion. So projectile motion is all about the motion of the objects in the air, a two-dimensional motion of the objects in the air, and the motion should be in a curvilinear way. So it's a kind of a curve, like the way you throw the ball in the air, it is forming a curve in the air. So it's not a straight line motion, even though it's a two-dimensional motion, but it's not a straight line motion, it's a curvilinear motion. So the projectile motion is a two-dimensional curvilinear motion under the action of gravity. So only force which is acting is the gravity force which is acting on the body. So this is what is the projectile motion, to introduce about it. So now like today itself, like in this recent times we have seen this ISRO Chandrayaan 3 has already reached moon. So how the ISRO has launched the Chandrayaan 3, how it because or there are other, even apart from Chandrayaan 3, there are other things which ISRO does or DRDO does is about missiles. So there are some missiles which are like intercontinental missiles. You release it from Asia, it will go all the way up to Africa. It can go all the way up to America. So how do they set the angle and the speed of the missile, and they have such an accuracy? If you release there is a war in Ukraine and with Russia. So Russia is releasing the missile and it exactly strikes at one particular town of the Ukraine and at one particular place. So how are they able to meet that accuracy? So they are actually they are using these concepts of projectile motion to arrive that what should be the speed and what should be the angle of the missile so that it reaches. And similarly, like when the Chandrayaan 3 was launched, so how although there was some propulsion, there were more complex mechanics involved, but also they have used the concept of projectile motion to launch the Chandrayaan 3, the rocket which was launched from Earth, which contains the Chandrayaan 3. So so going ahead with the topic. So now coming to the definition of the projectile. So what is a projectile? Now this is one of you student who is thinking that what does the projectile is all about to do? But there is another student who is throwing a chalk or a ball at him, ball at her. So you can see what is a projectile motion. It's any object which is projected by some means and continue to move due to its own inertia. So which is like you see this object which is thrown and it is continuing to move because of its own velocity. That's why whatever momentum it has, it is moving. and then also it is being acted upon by gravity. So this is the definition. Any object, so this you can note it down, and this is important for your for any kind of evaluation also. Now, one thing which is important to note is, as I have introduced before also, that projectile motion, it's a two-dimensional motion. It's not a one-dimensional motion. Why it is two-dimensional? One dimensional is that it is moving vertically upwards, and another direction it is moving horizontally. Suppose you are throwing a ball to some other friend. You are playing a game called catch. So two of you are playing catch. So what is one person doing? He is throwing a ball, another person is catching. So when he is throwing the ball, it is being thrown at an angle in a vertical direction. So then there is a vertical direction and other is a horizontal direction. So there are two directions which is there. That is why, or two dimensions are there. So what is this two dimensions? One is horizontal dimension, other is vertical dimension. So that is why this projectile motion is called motion in two dimensions. So now here you can see, when the projectile is being introduced, it is going vertically upwards, which is shown by the red arrow, and it is going horizontally, which is shown by the blue arrow. So what it happens when the projectile is being launched, it is initially moving in two directions. One is in vertically, then horizontal, vertical, horizontal. But at the highest point, there is no longer a vertical motion. That is the highest point at which your projectile can go. From there onwards, it again starts coming down. Then initially it was, the two dimensions was, first was upwards vertical and horizontal. Now it will become downwards and horizontal. So like that it will happen. So this is the difference which is coming. Initially, before reaching the maximum height, there was a upward vertical motion, but after reaching the maximum height, there is the motion will be downward vertical, but in horizontal direction the motion remains the same. It was going from left to right. Similarly, now also it will go from left to right. The horizontal direction will remain the same all throughout. Only the vertical direction keeps changing. So initially vertical direction was upward, and after reaching the highest point, the motion which happens, the projectile motion moves in the downward vertical direction. Now, horizontal velocity component, like you have seen in your 9th and 10th, whatever you have studied the physics or kinematics, what you have seen is, what are the Newton's three laws? First law is a body continues to stay unless in a body which is at rest continues to stay at rest, and a body is in motion continues to stay in motion. So similarly, and that law is applicable till there is no external force which is being applied. So if we see if a ball is thrown, now we are trying to go into the dynamics of the problems. So what the dynamics are, that we are trying to understand what are the forces which are being acted upon the projectile motion body, the body which is in projectile motion. So when the body is moving, so it's always being acted upon by gravity. All of us who are there on this earth, we are always being acted upon by force of gravity. We are being pulled downwards. It's happening all the time. There is not even an instant when it is not happening. So even when you throw the ball, a force of gravity is acting on it, and the force of gravity is such that it always acts in the downward direction. So here we will see, suppose this is a ball and it is being thrown as a projectile motion. So it goes, I am just drawing the position of ball at different instant. Same ball is there. Don't think that there are some 7-8 balls. I'm not a juggler who is juggling many balls. So that is not the case here. It's only one ball, but it is being shown how it is moving. Firstly, it is here. Firstly, it is here. Then it goes up to here. Then it goes up here, and so on. So now at each instant, so suppose this is t is equal to 1 second, this is t is equal to 2 second, this is at t is equal to 3 second, this is at t is equal to 7 second. Okay, so what happens? This is the position of the ball at different time instants. So now we will see for one particular time instant. I'm just, for the sake of clarity, I'm deleting it. So what happens? At all the instant, force of gravity is acting downwards. So same force of gravity which is being acted upon the ball at all the instant. So in the vertical direction there is force of gravity, but in the horizontal direction there is no force. And force of gravity remains the same throughout its journey, or it always remains the same. Force of gravity, like when it is being thrown and when it comes down, all that time it was acted upon by a constant force of gravity. And what was that force of gravity? Force of gravity was equal to its own weight, which is equal to m into g, mass into gravity. And what is g? G is 9.81 meters per second square. This is the value of g, and m is the mass of this ball. But in the horizontal direction, initially when you have thrown the ball, you have put a force on the ball, but after the ball is released from your hand, there was no force which is acting on it. It has a momentum, but it does not have a force which is being acted upon it. Suddenly if it hits a person, or if it hits a bird, it will impart force, but that force will be imparted due to the impulse action of the ball. But on the ball there is no force acting. There is in the horizontal direction. In the vertical direction there is a force due to gravity, but in the horizontal direction there is no force which is being acted upon. So it is in the horizontal direction, it can be equivalently said that it is like instead of saying it has moved like this, we can also say that in horizontally, basically it has only moved this much distance. So this is the only distance which is being moved. So suppose one person is jumping and one person is moving horizontally, but if their ultimate aim is to reach at a particular distance, so both of them have done the same thing. So in the horizontal direction, like this is shown, if a body has a velocity of 1 meters per second in the horizontal, it is going, and the body which is having 1 meters per second horizontal and suppose 2 meters per second vertical. So the time, suppose in 5 seconds, if this particular body, it may cover 5 meters of horizontal distance. So in 5 seconds, this ball will cover 5 meter of horizontal distance in horizontal direction. But if a body is moving in a horizontal direction with the same velocity, 1 meters per second, it will also cover the same horizontal distance of 5 meters in 5 seconds. The only difference will be one is above the other. So the ball which is being thrown above, it will be exactly above the ball which is moving in the horizontal direction with the same horizontal velocity. Horizontally it will not make any difference because both of them have the same horizontal velocity. But in the vertical, because this ball has a vertical velocity but this ball does not have a vertical velocity, so this ball will be moving vertically, but this ball which is being thrown horizontally is not moving vertically, it is moving horizontally. Other part which is to be seen is the vertical velocity. Suppose it is 2 meters per second. So initially it was 2 meters per second when it is thrown. At this point, at the highest point, the vertical velocity becomes 0 meters per second. So between the lowest point to the highest point, the velocity is changing, the vertical velocity is continuously changing from 2 meters per second to 0 meters per second. So somewhere it might have become 1 meters per second, somewhere else it would have become 0.5 meters per second. Like that it is continuously being changing. But whereas the horizontal velocity is remaining the same. It was initially 1 meters per second, and at the point when it will reach here, it will also remain 1 meters per second. The reason behind is there is no horizontal force which is being acted upon the body. If you I hope this concept is clear to you. So I will explain this in more detail. Now we will just read it here. The horizontal velocity component never changes, covers equal displacement in equal time periods. This means that initial horizontal velocity equals the final horizontal velocity. So this is what we have seen here. What was the initial horizontal velocity? Final horizontal velocity also remains the same. So now we will see why does it happens from the point of view of from mathematical equations. So you might have seen this in your earlier class 11th or 12th. In the kinematics you might have seen this equation, V is equal to U plus A into T. So what was V here? It was final velocity. And what was U here? It was initial velocity. T is the time lapsed and A is acceleration. Okay. Now in the vertical direction, what was U? U is 2 meters per second. And suppose 2 plus what was acceleration? Since the acceleration we have taken the origin like this. This is plus x and this is plus y and this is minus y and this is minus x. So since the coordinate system is defined like this and the force of gravity is acting downwards, so the acceleration will be minus 9.81. Since we have seen that g is equal to 9.81 meters per second square. So here g is minus 9.81. Okay. So suppose time lapsed is 0.1 second. Okay. So what happens in 0.1 second is the time lapsed. So in 0.1 second what is happening? What the final velocity is becoming? V is equal to 2 minus 9.81 into 0.1, which is nothing but V is equal to 2 minus 0.981. It is nothing but 1.119 meters per second. See, now what I am trying to tell is in 0.1 second the vertical velocity has become reduced, almost it has become half. So this is what is happening with the vertical velocity. The vertical velocity is reducing as the time is progressing. Okay, but what will happen in case of horizontal velocity? Just see to it. If you have any doubts, you can ask me. Now we will apply the same equation for the horizontal direction. V. So what was the in horizontal direction what we have assumed? We have assumed 1 meters per second in horizontal and 2 meters per second velocity in vertical. So what will become U will become 1 plus, now in horizontal direction there is no force which is being acting. So A will become 0 into, now time we want to see like after 0.1 second itself, what is the change? We will put 1. So 0 into 0.1 will be 0. So V is again becoming 1. V is becoming equal to U. Instead of 0.1 second, suppose we want to see after 5 seconds, what will be the situation? We put 5 here. 1 plus 0 into 5, it again becomes 1 plus 0 is equal to 1. So we can see here even mathematically the horizontal velocity, it is remaining the same. It is not changing. Only the vertical velocity of the projectile motion is changing. Just see to it. If you have any doubts, you can ask me. This is something very basic to the projectile motion. If you understand it, you know it's a new concept for you, but once you grasp the basic of it, you can easily solve the problems which is based on the projectile motion. Now when we talk about velocity, so velocity has two things. One is the magnitude, other is the direction. This is the velocity. It has a direction in which it is moving. Other is the magnitude, like it is whether it is 1 meters per second, whether it is 2 meters per second, whether it is 5 meters per second. This is the magnitude. And what is direction? Whether it is at this angle, whether it is this direction, whether it is this direction, whether it is this direction. So these are the directions. A velocity is a vector which is defined by two quantities. First is the direction, other is the magnitude. Magnitude is these values which is representing the amount of velocity, the amount of that unit which is present, and direction is the direction in which that velocity vector is moving. Now even when we talk in terms of vectors, velocity vectors, in the horizontal direction the horizontal velocity vector is not changing. But in the terms of vertical velocity vector, the vertical velocity vector is also changing. What we have seen in the previous slide, we have seen the formula for the magnitude of it. But what about the direction? The direction of the velocity vector is also changing. It's not changing at this location. Initially, vertical velocity vector is always upwards, but after reaching the highest point, it becomes downwards. Okay, but the vertical velocity vector from this location up to this location, it's always vertical, and the horizontal velocity vector is always horizontal. Vertical velocity vector is always upward vertically. But what is happening is the velocity vector magnitude is changing. Initially it was 2 meters per second, after 0.1 second it becomes 1 meters per second, and so on. And depending on if it is 10 meters per second, maybe after 1 second it will become like 2 meters per second, and so on. So we can see how the vector is represented. It is represented by its length. So here the length is more, the velocity is more. Here the length is less, velocity is less. Okay. Now what we can see is the resultant of these two, horizontal and velocity vector, will represent the direction of the resultant direction of the projectile motion. Now you might have seen in the vector mechanics in the previous units. Suppose this is the vertical velocity vector, vertical, and this is horizontal. So this is the angle of the resultant, tan theta. So tan theta of resultant is dependent upon vertical upon horizontal. Vertical velocity vector upon horizontal velocity vector. Okay, this is the resultant. Okay. Now, as I have already said, the horizontal velocity vector remains the same. It is remaining the same in the entire projectile motion. So basically, my h is always same, but the vertical velocity vector v, this is changing, v is changing. So we have already seen how to combine the various components, vertical and horizontal, and how it is affecting the projectile motion in this slide which we have seen this. Now moving on to the next topic, but what I would say is this was what I have covered till now. It was an introduction to the projectile motion. So basically you go back, read about it, and grasp the concepts and become more familiar with it. And if you have any questions, come back to me and ask and discuss with me. So because unless you grasp the basics of it, going further will not help us much. So I would request you to go through the basics which I have already been shared, and discuss with me if you have any doubts. And then in the next lecture we will continue it further. Thank you everyone.